This is a video about waves. And waves are carriers of energy. And what I want to show you today is the wave model. So we can represent waves in the wave model. And the best way, sort of mathematical way of doing that, is using some axes. So we have a y-axis, y to the sky, and the x-axis running along. And if we draw on a diagram of a wave, it's going to look like this. And we'll keep going on and on and on. And I want to point out to you some of the main features. So what we have here is a wave moving along in this direction. So we can say that the energy is moving along in this direction. And what would happen if there was no energy moving along here is that the wave would be at rest on this line here. So what we can think about each wave as is like a step of a runner. So if I start at the starting point here, and then I take a step forward, I could end up here, and another step forward here. And we actually say that this is the wavelength of the wave, which is represented by this Greek letter lambda. And how we find the wavelength is we look at a point along the rest line, and we go to the point where the wave reaches a full cycle along again at that point. And that is like one step of the wave, that is one wavelength. And so this is also another wavelength. Okay, so this is wave 1, this is wave 2, etc. And so we could say that this part here is exactly half of a wave, and this is one full wavelength. Another key point is to note how high up the wave moves from its rest point, and this is actually called the amplitude. And the amplitude is this height here, but also this depth here, because it's representing how far away from the rest point the wave can be, the maximum point away from its rest point. That's the amplitude. So we can write that. Okay. Now the top of the wave here is called the crest. And we sort of can relate to that, the crest of a wave. The bottom part here is called the trough. So the crest and the trough, those exact points at the maximum amplitude, represent the height and the depth of the wave. So we've got the wavelength, each step, the amplitude, the crest and the trough. There's one other thing to talk about, which is if the energy is moving along in this direction here, what is happening to the particles in the wave? So if we imagine this wave was at rest and there were all these little dots of particles, as the energy disturbance moves along, the particles in this direction, in this side, are moving up. Okay? They're moving the furthest point up to the crest. And even here, they're still moving up away. But at this half of the wave, particles are being pushed down. So we can see that the particles are moving up and down, and the wave is moving along. So in a transverse wave, this is the model of a transverse wave, the energy is moving perpendicular to the particle motion. And that is starting point for some of the main features of a wave.